After Japan, slowly Geetha and street part as well. And Jovi. After that, so many companies came. That time only Amazon came.
Please ask your friends to join early.
Now standing first.
Back to this topic.
Winter season, drops in westerlies. What we discussed what are long waves and short waves. And then we also discussed about the western disturbances. Western disturbances are nothing but synoptic scale weather systems which come from the west, that is from Iran, Iraq, Afghanistan. They start over the Mediterranean, Black Sea, Caspian Sea, over the sea areas, and they move across Iran, Iraq, Afghanistan, and all, and then move across the extra northern parts of India. They come in the form of cyclonic circulations, upper air cyclonic circulations, or truffles, upper air troughs. Sometimes they are seen at the surface level. In the lower to mid, generally they will be seen at the lower to mid levels, and sometimes they will be seen at the surface level also. If you have a closed isobar associated with the system, it is a then it's a surface level. You can very clearly see. Sometimes, if you are able to draw two closed isobars, then it is called a western depression. And then we also saw that as the system moves, what are all the weather we expect when the system, where the western disturbance is approaching the station, what kind of weather we can expect, and when, after it passes, what kind of weather we can expect. When it is approaching, we can expect what kind of synoptic features, and when it passes over, then afterwards, what kind of synoptic features and what kind of weather. All these things we discussed. And then we also saw what are jet streams, how they are formed at the interface of two types of air masses, that is tropical air, between the tropical air mass and the subtropical air mass, and at the upper levels. Generally, they are formed in the upper levels because the wind speeds have to increase. Wind speeds increase with height because of the sharp height gradient or the pressure gradient at the interface as you go up. So you get formed, the jet streams form generally in the upper troposphere, something like around 200 HPA level, just below the tropical tropopause. And we also saw how they are helpful in with respect to intensification of synoptic scale weather systems. At the right entrance of the left exit of the jet streams, we have divergence, which is very helpful for the systems to intensify. Aside from that, when there is an upper air trough moving over this western disturbance, and ahead of this trough line, there is divergence. On this divergence, if the western disturbance is just below this upper air trough, but the divergence associated with the upper air trough, then again the system can intensify. Or if there is a velocity divergence also, that will also lead to intensification of the system. And we also saw very important features of synoptic features associated with incursion of moisture, because remember it is coming from it may come from Mediterranean Sea or Caspian Sea or Black Sea, but afterwards it is moving across land areas only. How will it get moisture supply when over the Indian region? Sometimes a trough may extend from this western disturbance into the Arabian Sea. If a trough extends, then through the circulation associated with the trough, that will bring in moisture into the western disturbance. And likewise, now sometimes as the western disturbance moves across further eastwards, during winter season you have massive anticyclone over central parts of India. This anticyclone will be pushed by this western disturbance. And if this anticyclone moves into the Bay of Bengal, then this anticyclonic circulation will incur moisture from the Bay of Bengal, and then it will transport it to the share it with the western disturbance. Or western disturbance will get more moisture supply if this anticyclone central area shifts eastwards and then brings moisture supply, and then the winds take it further in towards the western disturbance. These are two important cases how the moisture incursion can happen. And then what are all the weather we expect? In what situations rainfall will be confined only to a few subdivisions in western parts. In certain other situations, how the rainfall extends even up to the eastern East India or even northeast India also. So these are some important discussions we had about the winter season, weather during the winter season. Now, and we had already earlier discussed discussed about southwest monsoon season and northeast monsoon season, and I also know that you have completed hot weather season also, how thunderstorms form both the Indian region because of wind discontinuity, extensive heating, wind discontinuity, leading to very then two types of air, one from the warm moist air coming from the south and then the cool air coming from the west over the northeast India. The moisture is also brought by this anticyclone over the way, and all these gives rise to what is known as intense thunderstorm activity called by Shakis. All these you have studied. And over the northwest India, you have because of moisture is less. Very rarely thunderstorms with rain happen, but then very intense thunderstorms leading to sandstorms and duststorms do happen on northwest India on these local names for these events are referred to as Andis. And on the southern peninsula India also, frequent and intense thunderstorms happen all over the southern peninsula region because of the wind discontinuity. This also you would have studied. So now, when this kind of intense weather systems happen, and we also know that these systems happen, so we have a procedure to monitor the weather, all the synoptic features associated with this weather. By monitoring, if you are able to see or predict the occurrence of the weather at a later instant of time, we are giving a forecast. But to what extent the forecast will be useful to the user? Supposing we say, see, we are giving different types of warnings. Different types of severe weather affect our Indian region, starting from tropical cyclone, heavy rainfall, heat wave, cold wave, fog, then health issues, then railways and roadways get affected, air quality get affected, power, marine, tourism. These are all different stakeholders affected by our weather. And then we are giving one for thunderstorms, flash floods, all these things. And they have different stakeholders have different kind of impacts due to these intense weather. So what is expected is a good forecast or warning is not enough. The different stakeholders will want to ensure that their activity and their property is safeguarded because of our warnings. So simply telling them the tropical cyclone is going to cross a particular area or heavy rainfall is very simple will take. Heavy rainfall is likely to affect over a particular say let us suppose Chennai. Then what is the use of giving that information? Heavy rainfall, okay. And then then this heavy rainfall, what are the impacts of this heavy rainfall? How will the people be affected by this heavy rainfall? They won't know the term heavy rainfall. What you mean by heavy rainfall? Whether it's a very intense spell for 5 minutes or intense spell for entire day or very moderate spell for a long duration. What do we call as heavy rainfall? So there are a lot of they will say all meteorological terminologies which are not very much directly they cannot be transformed into usable information for the public. So what is expected of us is to give the impact associated with that. Now, rather than the weather is very important. Weather warning, so we have to give the weather warning. Associated with the weather, what kind of impacts can be expected? That also we should give in our warnings. That is why the National Meteorological and Hydrological Services, they have to work more efficiently with disaster managers, public and stakeholders, so that people can help we can help people to understand how these weather hazards can affect them and so that they can take appropriate action. So very important thing, how we can do that is we have to work with the stakeholders. Agricultural means we should know what all the impacts the farmers will face, whether the crops are in what stage or what kind of weather is expected for them. If it is in sowing stage or it is in growing stage or it is in harvest stage. At that particular stage, what kind of weather is very conducive for them, what kind of weather is harmful for them. All this information we should collect from them so that and when this particular event is happening, what kind of what is the stage of the crop and what is the likelihood scenario because of this heavy rain that we should be able to give to the farming conduct. Likewise, major city like Chennai means you will have lots of activities taking place, and then simple thing, people moving from one place to another will also be affected because of extensive, very dense population, and then traffic activity. So traffic will be affected, and then sometimes it may go into a standstill. Nobody will be able to move for 3-4 hours also. That kind of situations may also happen. And then the power supply may be cut off because of the extensive rain activity. Thunderstorm may happen. power supply may be cut off. If power supply is cut off, then what are all the other activities associated with industrial activities, and then hospitals, they will all be affected. And there's so many things are there. So we have to give proper information about the impact, not just simply tell heavy rain will happen. So what is expected from us? What the weather will be is the information we are providing. Based on our observations and forecast models, we are able to give a forecast. So what the weather will be, we are able to tell. Say 50 mm in 24 hours of rain is expected, 35 knots wind is expected. All this information we are giving. But how will the public interpret? And for a person, but different stakeholders will need information about different aspects that will help them to take action. So what we should do, we should move from what the weather will be to what the weather will do. That is, we should tell. It is not enough we say 50 mm of rain in 24 hours. We should be able to tell them there will be flooding, flash flood may be there, or local inundation may be there, low-lying areas may be inundated, whatever we expect for that particular scenario of rainfall and then particular scenario of the region where it is happening. And then sometimes the intense rainfall activity and then very low-lying area, then it is likely to be completely cut off from the rest. Means we can use the communities cut off. Anything. Some simple words are given here. So we have to move from just the meteorological information to the likely impact due to the meteorological hazard. That is known as impact-based forecasting. So weather forecasts and warnings should be translated to impact-based forecast and warning services. What are the key ideas for this? First, we should be very clear. We should be very clear about the meteorological hazard that is likely to prevail. Meteorological or hydrological element. Okay. Intense or prolonged rainfall, strong winds prolonged rainfall may lead to flash floods or riverine flooding also, depending on the water levels in various water bodies. All these are there. So we should be able to clearly, we should have a clear idea of the meteorological and hydrological hazard that is likely to pose a threat. And then we should also have whether it will, what is the extent of certainty in that particular event happening. Okay, we know that water bodies are full in a particular district and we are expecting very intense rainfall, very heavy or extremely heavy rain is expected during monsoon season, let us suppose. Then we know that already water bodies are full and this kind of rain is expected over this area. So any more extra water means definitely water bodies, there will be overflowing of water from rivers or dams or whatever it is. But will this, what we predict, this very heavy or extremely heavy, what is the extent of certainty of that forecast? Whether it will surely happen, whether it is very likely, most likely to happen, very likely to happen, likely to happen, we have different grades of probability. So depending on the probability, we should be able to, if you say most likely or most likely to happen, then impact we can very clearly specify and then ask them to take a necessary action. We are not very sure. We can say very likely, not most likely, maybe we can say very likely. That means what, some up to 50 to 75% chances are, let us suppose. Then we can say that you be ready anytime. When we upgrade the warnings, you should immediately take action. But you be ready, such a situation, impending danger is there, be ready to take action. But then the probability is very less, but we cannot rule out such a thing to happen. Such a situation is there, say up to 25 to 50%, something like that is that. Then you can simply say likely. And then we can tell them that we be updated. Right now we are telling that such a situation may arise. So you be updated. So then the next time when we feel that the probability is increasing, the certainty of the forecast is increasing more and more, then we have to update. Telling them no, it is going to happen, you please take action. So that is what is expected of us. So what are the important aspects that you should keep in mind for impact-based work? First thing is exposure. What is the area that is likely to be affected by this meteorological or hydrological hazard? Area means geographic area as well as, that is the main thing, geographic area. So you can say it's a particular district or particular zone or particular, whatever be the geography. That we should be able to clearly tell. And then in that area, the liability of exposed human beings, their livelihoods, property, to suffer bad effects when this hazard strikes. What are all the people in that locality? What kind of people are living in that locality? Whether that locality is very thickly populated. If it is thickly populated, then what kind of infrastructure is present in that? Very, very, what to say, high-story buildings, and then what to say, very pakka structures are there, or not very pakka. Some hutments are there. Many people are dwelling in hutments or in open areas. This kind of things. All this information we should have there. Again, property. Well, what kind of property? Suppose if big industries are there, and then if water runs into that, we saw what happened during one cyclone. Big Chang was that when the industrial when flood water entered that area, in all the industries were affected because the neck deep water was there. All machinery, big factory machinery were all affected because of that. So we should know where that particular hazard is going to happen. What is the scenario in that? What is the vulnerability of that area? That is, if you are having machinery, we have to protect that. If you are having hospitals, people have to be taken care of in the hospitals, and all these things should be. These all these factors will come under vulnerability, and then risk. That is to the extent of the impact. That is highly vulnerable area. There is all kinds of people are there, very thickly populated, very great infrastructure is there, and many people are living in hutments and open areas. So vulnerability is very high. And the exposure also, we know that very intense rainfall, heavy rainfall warning is there. But with this heavy rainfall warning probability, if it is very high, then the risk is going to be very high. So we have to say the probability and magnitude of harm possible to humans, their livelihoods or assets because of exposure and vulnerability to the hazard will give them risk. So these are the three important things we should keep in mind: hazard, vulnerability, exposure, vulnerability, and risk. Four words: hazard, exposure, vulnerability, and risk. So how do we evaluate the vulnerability? Location. At what time? Current environment. What are the current environmental conditions? And then at what time it is happening, whether the people are on the streets or they are at the late night, it is going to happen in the late night, people will be at home means we can say vulnerability with impact may be slightly, risk may be slightly less. But during peak hours of office, people are all on the roads, it's going to happen at that time. Vulnerability is going to be more. So which area, at what time, what are the current environmental conditions, all these things we should keep in mind when evaluating. So basically I told you 4 words, keywords. Hazard. Hazard is a meteorological information. Heavy rainfall, tropical cyclone, heat wave, cold wave. All these are all hazards. Exposure. Exposure is the over area. Over which area we are expecting this hazard. That is the exposure area. In that area, what is the vulnerability? What kind of whether what is the population density in that area? And then what is the kind of infrastructure present there? What is the agricultural what kind of agricultural activity is happening in that area? Then whether any other major industrial activity is there. Supposing say all the coastal areas with some salt pans may be there. So we should know all that. Or other industries like oil and gas industries may be there. So we have to know all these things. That will be, especially near Chennai is Kalpakam atomic station is there. So we have to safeguard these areas because any harm happening in that area is going to create great major havoc. So we have to give proper warnings to them so that all those activities are shut down, and then we can minimize the loss because of any further damages. So hazard, exposure, vulnerability, all of them happening over a particular area, that is the area where the risk is maximum. So you can say here, this is the hazard. That is, you can say Venn diagram. No, in mathematics, all of us would have learned. So hazard, union, exposure, hazard, intersection, exposure, intersection, vulnerability is this risk area. So that is where the maximum risk is present. We have to give warning for that area very clearly. So supposing we are giving whether one strong winds are expected tonight, which wind speed 20 meters per second likely. We give in knots, but this is just an example. If we transform it into impact-based warning, it should read something like this. Strong winds are expected tonight, which may result in delays or cancellation to ferry services. Keep small fishing boats tied properly. Something like that we should write. So basically, we have to now prepare a matrix, risk matrix, because at the end, what is going to what is going to be communicated to the public is the risk. How are you going to determine the risk? So you classify the impacts. Which area the impact is going to be maximum? In which area you classify the impact. Very low impact because not a low-lying area. It is not a very highly low-lying area. More water does not stay in that area. Means you can say very low. But it is a very low-lying area. Water will definitely inundate that area. Give it high. In between, so you have different categories. Very low, low, medium, and high. And then likelihood scenario. The forecast that you are giving, that intense rain, heavy rainfall, extremely heavy rainfall, whether the probability is very low, or medium, or high. So then you prepare this matrix is prepared based on the current exact scenario. When this situation arose, when we had medium impact weather event, and then the likelihood was very low. Then what was the damages that had happened in the past? That will be very useful information. Based on that, now we can prepare this matrix. Supposing now in this particular case, the impact is low, but if the likelihood is medium or high, then there has been some impact. Means we have to go for this yellow warning. That is be aware. So we have four color coded warnings. It is green means always no. That is no severe hazard. Then yellow means you be aware. Orange means you be prepared. Red means take action. So now you have to take very low, medium, high. So we have to prepare this matrix. This matrix will not be the same everywhere, depending on the particular area. See, for example, now I'm going to prepare this matrix for coastal areas, say, um, Nellore. Then I have to keep in mind agricultural activities. I have to keep in mind about the other infrastructure available there. And then accordingly, I have to prepare this. But if I'm going to prepare for Chennai, then I have to keep the infrastructure with them. Very big city, mega city it is. So what are all the different industries that are happening in and around Chennai? See, everything, how many hospitals, how many schools, all these things will add to the vulnerability. So we have to give the vulnerability a greater value for Chennai. And then, but agricultural impact will be low for Chennai, but it will be maximum for Nellore. So for different areas, the impacts are likely to be different. And then if you are going to prepare this for say Uttarakhand area, then we know during monsoon season very intense rainfall activity happen in the higher ranges of the Himalayas. Then that water comes downstream, and then downstream there will be flash flood because of intense rainfall happening upstream. So then we have to give properly warnings for the downstream area also. Here the impact may be less, but then we are expecting that rain is going to cause flooding. So different heavy rainfall is one thing, impacts are different. So for different areas, the impact will be different. So we have to prepare the risk matrix for different areas, and then we have to issue the warnings accordingly. So, but for this, no, we need to have a complete database of the particular area. Not only the meteorological hazard, we should know about the particular area very clearly. Whether hills are there in that area, whether coastal areas are there, what kind of occupation for the people, what is the population density. All this information are required. So, no, we need more resources and knowledge such as demographic data. Then we need to use crowdsourcing techniques because if, any information about nook and corner of a particular area, nobody will be able to tell. So we have to take information from the public who are living there. So crowdsourcing techniques needs to be there. The GIS need to be there because we have to map all this information with the GIS platform. Then only we will be able to tell over which area what kind of impact is likely to happen. And then interoperability, we have to work with each other seamlessly. That from different scales we have to interact. That is from meteorological information to the stakeholders, different stakeholders, and each one we have to interact with them. And then we have to take inputs from them. We have to give our inputs to them, and then together we should work together. And then only this kind of impact-based forecasting can be achieved. Third-party data integration and usage is very much required. We have to deliver impact services that NMHS cannot do on their own. That is National Meteorological and Hydrological Service. That is something like IMD. We cannot do it on our own. We have to interact with other stakeholders also. So let us see. I'm just showing a threshold, the impact threshold for rain. So minimal impact. What can we expect? Water on roads, driving conditions affected by water, isolated flooding in low-lying areas, traffic congestion may happen. And then minor. Say for example, in 1 hour 50 mm or in 6 hours 150 mm, something like that is expected. Then some minor roads cannot be used at all. Low-lying bridges experience typical flooding. Major roads affected, causing increasing travel time. Areas cut off temporarily. Minor flooding occurring in some basins. So this kind of information we have to add. If the impact is likely to be significant, you can see the gradation of the impact. Slowly it is increasing. Flooding of major roads, disrupting of transport routes. Some minor road bridges impossible. Danger to life, danger to roads, communication and travel disrupted. Flash floods may affect in some areas. one or two municipalities may be affected completely. This kind of information we have to. If we expect the impact to be severe, we can say danger to life from fast-flowing deep waters. Evacuation and search and rescue operations may be needed. Roads impassable, roads closures, large-scale damage to major and minor roads, widespread flash floods, large communities cut off. These kind of situations will happen. Will be very extreme situation, something like cyclone landfall or something like that, or very 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 intense thunderstorms, just in 6 hours, 20 centimeters, something like that happening. So they will lead to this kind of situations. So we have to now list all these and prepare the table ready. And then response. Then how will the people? So how are you going to act? If the impact is likely to be low, what will the event service will continue to monitor for any changing weather. So when it is very low, we are going to keep it ourselves. We continuously monitor. If it is low but be aware, then we have to be aware of flooding and stay out of flood waters. Evaluate inventory of emergency supplies. Keep all the supplies into when if the rainfall increases, you cannot go out to buy. So whatever is required for your routine activities at home, be prepared with all that. Then see whether in your area flooding is happening. Just see outside how the what the water level is. All these things the public have to do. This is the response. And then if it is medium, be prepared for flooding and stay out of flood waters. Take emergency supplies. Purchase all additional supplies. Be prepared for localized flooding. So if flooding happens, how I will manage? Be prepared for that and keep all the required things. And if the response has to be high, take action. Then avoid. Don't go out at all. Don't drive and stay off roads in flood-prone areas. And then plan to shelter in place in non-flood. If you are in a flood-prone area, move immediately to a region of non-flood areas. So this kind of response also have to happen from the people's side. So this is just what we generally use. I'm showing you this one in heavy rainfall. We have a matrix which we have prepared for ourselves. Potential impact minimal, minor, significant, very low. Something so if the potential impact is minimal, likelihood is very low, green. And then potential impact minimal, likelihood low, green. Potential impact minimal, likelihood medium also we can go for green if no impact, major impact has happened in the past. But likewise, even if likelihood is very high, if the impact is very very minimal, then we need not unnecessarily warn also. We can say we can leave it green. But if you are expecting some minor impacts, then if the likelihood is minimum, that is probability is at least medium, then you give a warn. That is, you say be aware. Risk level is low, you be aware, and for higher also. But if the potential impact is significant, and the likelihood is very low or low, then we can say be aware. Any further updates, if it goes to orange or red, you can take action, be prepared for that. But then when it goes to orange but if the likelihood is medium or high, directly go for orange. Say you be prepared. Anytime it may affect you, so you be prepared. But if the potential impact is severe and the likelihood is very very low, less than 25%, let us suppose, then you can simply say yellow, be aware. But if the likelihood is say 25 to 50% chance for it to happen, then you give orange for that particular area, depending on the past. Everywhere it need not be orange. Suppose in that particular area, the major impacts have not happened. Even for severe likelihood low, also we can give yellow. So for different areas, depending on the vulnerability, you have to prepare this matrix. The risk level is very low, low, medium, and high. Accordingly, response level. Very low means no action, low means be aware, medium means be prepared, high means take action. So these kind of situations we have to prepare and give. So in addition to the weather, we have to give information about the impacts also in our bulletins. Very recently we have started in IMD for heavy rainfalls, cyclones. Now heat waves also we are doing impacts. So slowly we are expanding our impact report to several weather hazards. So that is about some basic information about impact-based forecasting. I think this will do for you because you are not getting into forecasting now. We will not go into each and every hazard separately and discuss. If you have any questions, you can ask. Otherwise, I think if you please go through the syllabus completely and see whether we have missed out anything. See your notes. Go through the syllabus. Go through the notes. And if you want any point to be discussed, we shall have one more class for discussions. Otherwise, I think having this, I have completed. I think all topics have been covered. Go through the full syllabus, right from the first to the end. All topics, all the three of us together, whether we have completed. completed everything. Any point you want, something is given in that, but you need some more discussions, you can ask us, so we can have one more discussions on that. Otherwise, we have completed our syllabus for synoptic unit. Any questions? Could you follow what I was trying to tell you?
Yes, ma'am.
Okay. Then if no questions, we shall stop here. Go through your syllabus, go through the PPTs, go through the notes, be thorough with your notes,
Okay, ma'am.
and whether all aspects, even the syllabus are covered in that. If you have any doubts, we can interact later. You can tell Shailja madam also, she may arrange a class also. We can interact later. Otherwise, we shall stop here. Our syllabus is completed now. Thank you all.
Thank you, ma'am.
Thank you, ma'am. Thank you all.
Thank you.